Probability. The chance of happening of an event when expressed quantitatively is called probability. If an event A can happen in m ways and fail in n ways, all these ways being equally likely to occur, then the probability of the happening of A is probability of event A equal to number of favorable outcomes upon total number of possible outcomes equal to m upon m plus n equal to p. Probability of failing of event A is defined as q equal to n upon m plus n. Hence, p plus q equal to m upon m plus n plus n upon m plus n equal to m plus n upon m plus n equal to 1.
Example. Find the probability of getting a head when a coin is tossed once. Also find the probability of getting a tail. Solution. When a coin is tossed once, the number of possible outcomes is 2, head and tail. Let E be the event, getting a head. The number of outcomes favorable to E is 1. Therefore, probability of event E is equal to probability of getting a head is equal to number of outcomes favorable to E upon number of all possible outcomes is equal to 1 upon 2. Similarly, if F is the event getting tail, then probability of event F is equal to probability of getting tail is equal to 1 upon 2. Equally likely events. Two events are said to be equally likely if one of them cannot be expected to occur in preference to the other. On throwing a die, the probability of getting any number out of 1, 2, 3, 4, 5 and 6 on the upper face of the die is same. For example, getting 5 or getting 3 on the uppermost face of the die are equally likely events.
Impossible event. A common die is not marked with 7. Hence, getting a number 7 is impossible. This type of event is called an impossible event. The probability of an impossible event is always 0.
That is, probability of getting 7 is equal to 0 upon 6 equals to 0.
Sure event. The probability of getting a natural number less than 7 on throwing a die is a sure event.
Probability of
getting a natural number from 1 to 6 equal to number of favorable outcomes upon total number of possible outcomes equal to 6 upon 6 equal to 1. Hence, the probability of any event lies between 0 and 1. Mathematically,
probability of event A is greater than or equal to 0 and less than or equal to 1. Example. A bag contains 5 black, 7 red and 3 white balls. A ball is drawn from the bag at random. Find the probability that the ball drawn is red, black or white, not black. Solution. Number of black balls in the bag is equal to 5. Number of red balls in the bag is equal to 7. And number of white balls in the bag is equal to 3. Therefore, total number of balls in the bag is equal to 5 plus 7 plus 3 is equal to 15. Drawing of balls randomly from the bag are equally likely outcomes. Now, total number of possible outcomes is equal to 15. Here, the number of such favorable outcomes is equal to 7, as there are 7 red balls. Therefore, the probability that the ball drawn is red is equal to probability of red balls is equal to number of favorable outcomes over total number of possible outcomes equals to 7. Here, the number of such favorable outcomes is equal to 5 plus 3 is equal to 8. Since there are 5 black balls and 3 white balls, the probability that the ball drawn is black or white is equal to number of favorable outcomes upon total number of possible outcomes equals to 8 upon 15. Here, the ball drawn is not black. It means the ball may be red or white. The number of such favorable outcomes is equal to 7 plus 3 is equal to 10, as there are 7 red and 3 white balls. Therefore, the probability that the ball drawn is not black is equal to number of favorable outcomes over total number of possible outcomes equals to 10 upon 15 is equal to 2 upon 3. 1,000 tickets of a lottery were sold, and there are 5 prizes on these tickets. If Saket has purchased 1 lottery ticket, what is the probability of winning a prize? Solution. Total number of lottery tickets is equal to 1,000. Therefore, total number of possible outcomes is equal to 1,000. Number of prizes on these tickets is equal to 5. Number of such favorable outcomes is equal to 5. Therefore, probability of winning a prize is equal to number of favorable outcomes over total number of possible outcomes equals to 5 upon 1000 is equal to 0.005.
What is the probability that a leap year selected at random will contain 53 Sundays? Solution. Number of days in a leap year equal to 366 days. Now, 366 days equal to 52 weeks and 2 days. For the leap year to contain 53 Sundays, last 2 days are either Sunday or Monday or Saturday and Sunday. Number of such favorable outcomes equal to 2. Total number of possible outcomes equal to 7. Therefore, P, a leap year contains 53 Sundays equal to 2 upon 7.